Now coming to some other examples of molecular orbital diagram, because a lot of questions will be getting upon it. Alright, where you will be asked to calculate the bond order, you will be asked to calculate what you can say, whether it is paramagnetic or it is diamagnetic. You will asked to what you can say, arrange in the increasing or decreasing order of stability. In this different questions you will be getting it regarding this. Alright, so this is very important, children. So you have to pay attention. So hence I am giving some more examples to you. Just look at. For example, it is the formation of H2 plus ion. H2 plus. What I said? H2 plus. It is known as hydrogenium. It is also called as hydrogenium ion. We can say that. Or it is also known as hydrogenyl cation. Alright. Hydrogenyl, that is, rather I should say dihydrogenyl cation. Dihydrogenyl cation, or it is called hydrogenium ion, not hydronium. Hydronium is H3O plus, hydrogenium. Alright, because I said you, to any radical, that is, or any species, plus charge is there, positive charge is there, it is, the name ends in yum, so hence it is hydrogenium, we can say that. Cation, we can say that, or hydrogenium, and ion also we can say that. Clear? Now the main thing is that how to draw it, the molecular orbital diagram for it. So one side it will be H and other side will be H plus, definitely, because H and H is H2 and one is H plus. Suppose I would have asked you that is H2 2 plus, then I would have taken here H plus and H plus both the side. Very simple, it is simple maths. Alright, understand what I am saying. Suppose I have asked here H2 plus, so I have taken one side H plus, one side H, another side H plus. Done? Okay, H and H is H2 and here one plus is there, so it is H2 plus. Suppose I would have asked you H2 2 plus, H2 2 plus, if I would have asked you, so it's this side be H plus and this side also is H plus. The name of this is dihydrogenyl dication. Dihydrogenyl, hydro, H-Y-D-R-O-G-E-N-Y-L, dihydrogenyl dication, we can say that. Okay, in this way. So any form it may comes, the question can become. Okay, so but here I will draw for H2 plus ion. Got it now? So H, what is the electronic configuration of hydrogen? 1s1, and H plus means that also is not there. Alright, H plus means nothing is there, vacant, completely vacant. So here what we'll do, we'll take, that is nothing but 1s1, we'll take it, and here I'll take it as nothing, 0, nothing is there. So it is going to form a molecular orbital. Alright, you can see. So it will be sigma 1s1. Correct? Then sigma 1s1, this is your H2 plus, this one is H2 plus, this is H and H plus, in this way. Clear? This is how we are doing it for, that is nothing but H2 plus, the molecular orbital. Now what is electronic configuration? Very simple, sigma 1s1. What is its nature? It is paramagnetic nature. Paramagnetic, unpaired electron. What is its bond order? Nb minus Na whole divided by 2. So Nb is 1, Na is nothing, 0. So 1 minus 0 by 2, it is 1 by 2 simply. So it is bond order is half, we can say that. Clear? Everything we have calculated. Now suppose if I ask you here H2, that is 2 minus, let us say H2 2 minus. Alright, or H2 minus, let us do it first. First H2 minus. So it will be what? It will be one, I will take it as H, another will be H minus. Very simple. H and H is H2 and it is 1 minus sign is there. Alright, if 2 minus, then here also it will be minus. Simple. Here suppose I will be writing here 2 minus. This also H minus, this also is H minus. H and H is H2, minus minus is 2 minus. Understood? Very simple, it is very simple. Now it is here I want H2 minus. So what is the name first? Dihydrogenyl anion. Dihydrogenyl anion, we can say that. Or H2 2 minus will be dihydrogenyl dianion, we can say that. Clear? Okay, fine. Now H is 1. When I say H minus, so H is 1. H minus means one more electron. So it will be here 2 electron will be there. So it will be 1s2. Alright, clear? That is, let me rub this. This is not there initially. So this is H, 1 electron, H minus means 1, 1 more extra. Alright, so 1 is there, 1 more extra means 1s2. So it will be sigma, 1 electron will come here and 1 electron will come here. So it is sigma 1s2 and 3 electrons are there, 2 comes here, so 1 electron goes here, so sigma star 1s1. Done. This is a diagram. We can say that is H and H minus, so H is 1, H minus is 1 more extra, that is 1 is 2, this one is 1, 3 electrons, 2 electron will come here, 1 electron will go here, fine. What is electronic configuration? Sigma 1 is 2, then sigma star 1 is 1, we can say that. What is its bond order? Nb minus Na whole divided by 2, Nb is 2, Na is 1, so 2 minus 1 whole divided by 2, 2 minus 1 is 1, 1 by 2 is again half. What is its nature? Paramagnetic. Same thing, just like H plus, we can say that. It is paramagnetic. Alright, so in this way we can calculate the nature, bond order and all these things, we can say that. Clear? Now which is more stable? H plus is also half bond order, H2 minus, H2 plus is also half bond order and H2 plus is also half the bond order. Listen carefully. H2 plus, just now I did it. It is half the bond order, you got it. In H2 minus also you got it as half. Now which is more stable? H2 plus is more stable. Why? Because there is an anti-bonding effect. In the last day we have said you that. Anti-bonding effect will be there. And due to anti-bonding, the energy is increased. The stability is decreased. Alright? In case of H2 minus, you can see the anti-bonding effect is there. In case of H2 plus, anti-bonding effect is not there. Because anti-bonding is 0. Nothing, no electron is there in the anti-bonding. But here 1 electron is there. So anti-bonding effect is there. Due to the presence of anti-bonding effect, that is 1 electron present in the anti-bonding, that is sigma star 1 is 1, energy is increased. So as the energy is increased, slightly the energy is raised, stability is decreased. So H2 minus is less stable in nature than H2 plus. In this way you can compare the stability also. Alright, in this way you can compare the stability. I hope you got it. This. Now next we will see some other what you can say species. We will see it, some other species. Let us see the formation of what is that? That is beryllium. We will see it. Let us see the formation of beryllium, Be2 molecule, lithium beryllium. We can see it. Alright, let us see the formation of that. What it happens? So beryllium. That is beryllium is atomic number 4. So 1s2, 2s2. Done. So we will see the formation of Be2 molecule. We will see the formation of. So one side will be Be, in the middle will be having Be2 and other side will be Be. So 1s, 2s, so 2 will be there. 1s, 2 will be there. 2 atomic orbitals. So first let me draw it because I am having less space here. The space is not so much. So I have to adjust the space also here. So always you will start it from below, mind it. It has to be started from below always. Always you need to start from below. So you can see that. You just follow me. What I am doing, I am starting from below. Make it a habit in this way. 1 is 2. So 2 electron here, 2 electron here. This is your sigma 1 is 2. This is your sigma star 1 is 2. So 2 electron here and 2 electron. Because total 4 electrons is there. So in this way. Next after 1s what we are having? 2s. So it is here 2s2 and here also it is 2s2. So it is sigma 2s2, 2 electron and sigma star 2s2. Got it? In this way. We can say that. So this is about your Be2 molecule. Very simple. Once you practice it becomes very easy. Now what is electronic configuration? Electronic configuration is sigma 1 is 2, then sigma star 1 is 2, sigma 2 is 2, sigma star 2 is 2. This in this way. Sigma 1 is 2, sigma star 1 is 2. Then sigma 2 is 2, then sigma star 2 is 2. Alright. Now bond order is Nb minus Na. Nb is 2 and 2. You can see that. No star. So 2 and 2 is 4. 2 electron, 4. Anti-bonding is again 2 and 2. Alright, because 2 is 2, this one is. You can see 2 is 2. So 4 minus 4 by 0. It is nothing but 0. We can say that. Nb minus Na whole divided by 2. Sorry. So, it is 4 minus 4 by 2. It is nothing but 0. By 2 is nothing but 0. You can say bond order is 0. So, Be2 molecule, so to say, it does not exist. Just like He2 does not exist, Ne2 does not exist, Be2 also does not exist. And it is diamagnetic in nature because you can see all are paired electron. The outermost, always you see the outermost. So it is paired electron, diamagnetic in nature, bond order is 0 and it does not exist. We can say that Be2 molecule. Okay, fine. So this is about your Be2 molecule. Now next let us see the formation of another molecule. Let us see, that is dioxygenyl cation. What is dioxygenyl cation? What I said? Dioxygenyl cation. That means dioxygenyl, O2. Cation means plus. Okay. So in one side it will be O, in the middle it will be O2 plus, and another side will be O plus, because O and O is O2 and here 1 plus means O2 plus. It is dioxygenyl cation. So oxygen, what is the electronic configuration? You know that. I don't have a space here, still then I will try to manage it here. It is 1s2, 2s2, then 2p4. 2p4 means it will be 2px1, 2py1 and 2pz1. You write in that way, 2px2, 2py1, 2pz1. Alright, 2p4 will be 2px2, 2py1, 2pz1. You will write it down. I don't have a space here. Alright, so what is 1s2, 2s2, then 2px2, 2py1, 2pz1. In this way you will write. Now this is, I have to manage. Here it will be how many electron is there? It is for 8 electron and there it will be 7 electron. 7 means 1s2, 2s2, 2px1, 2py1 and 2pz1. Again I say, what is that? 1s2, 2s2. Let me write it, otherwise then I will rub it. It will be better. Here it will be 1s2, 2s2, alright, then 2px2, 2py1 and 2pz1. So you can see, count it, 2 plus 2 4, 4 plus 2 6, 7 8. Alright, in this way. Now here it will be 1 electron less. So from where it will be less? From here it will be less. So it will be 1s2, 2s2, 2px1, 2py1 and 2pz1. So you need to arrange in this manner from below. Alright, you need to arrange. So you can see 1 electron less, plus means less. Suppose minus would have been there, then it will be 1 electron more. So it will be 2px2, 2py2 also. 2px2 is already there, 1 electron more. So it will be 2px2, then 2py2, 2pz1. It would have been O minus, then here it will be O2 minus, then it will have been, the name would have been, that is dioxygenyl anion. Alright, which is also called as superoxide ion. Remember it. O2 minus is also known as superoxide ion and O2 2 minus is called as peroxide ion. O2 2 minus is peroxide, P-E-R-O oxide, O-X-I-D, P-R-O-X-I-D-E, peroxide, and that is otherwise O2 minus is called as superoxide ion. Alright, so now how to draw it? Alright, so while drawing, remember it, what I said, that is 2s sigma 2s will come first compared to 2px and 2py, pi 2px and pi 2py. Alright, I have told in my last AB that is sigma 2s is going to come first. Alright, in case of, that is oxygen. Clear? Or not only oxygen, oxygen, fluorine and neon. I told you the reason also why it is so. So I have to start from here, from below. I don't have the space, so I will start with small diagram. Got it? Then here it is fine. So it should be in straight line with this. Then 2px, 2py, 2pz, 2px, 2py and 2pz. First we will be having this sigma 2s alright, then here it is and here one more. Done. I have got the space. I did it. O2 plus and here it is. Let me bring it here and this one little bit this side, it is oxygen. No, it's okay. Perfect. So now Here it is 1s2, 1s2. So 2 electron here, 2 electron here. Then here it will be 2 here, so it is sigma 1s2. I don't have the space, I am saying you just listen and write, and here sigma star 1s2. Still then I have written it, sigma 1s2 and sigma star 1s2. Then it is 2s2, 2s2. It will be 2 here and 2 here. It will be sigma 2s2 and sigma star 2s2. Then it will be, for oxygen I said 4 electron, and here it will be 3. Because 1s2, 2s2, what I said here? Sorry, I forgot to write here. Then here it will be what? 2px2, 2py1, 2pz1. And here what I said? O plus 1 electron less. So here it will be less. 2px1, 2py1, 2pz1. Got it? This one. 2px2, 2py1, 2pz1. I am writing it. 2px2, 2py1 and 2pz1. It is 2px1, 2py1 and 2pz1. See the configuration. 1s2, 2s2, 2px2, 2py1, 2pz1. 4 plus here 4, 8. Here it is 2 to 4 plus 3, 7. 1 electron less. Done. Fine. Now I will fill it up. Here it will be sigma 2s2. So 2 electron will come here. Total how many is there? Here 4 and here it is 3, 7. 7 you need to fill it up. So 2 is done. Then pi to px, pi to py. So here 2 electrons will come. So pi to px2 and pi to py2. We can say that. Clear? Now pi to px2 and pi to py2, we got it here. Fine. So how many electron? Here 2 to 4 to 6 and one more here. That is pi star to px1. Pi star to px1. So to say, we got it. This will be vacant because only 1 electron. Count it. How many it is there? 4 plus 3, 7. 2 plus 2, 4 plus 2, 6 and 1, 7. Clear? So it is sigma 2s2, pi to px2, pi to py2 and pi to that is pi star to px1. So this is the diagram, molecular orbital diagram of dioxygenyl cation. We can say dioxygenyl cation. Sorry, it's not superoxide ion, it is dioxygenyl cation. We can say that. Clear? Now electronic configuration I said you sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Then sigma, that is nothing but here it is that is 2s2. We can say that 2pz2. Sorry, it is sigma 2pz2. I wrote it 2s2. Sigma 2pz2 it will be. So sigma 2pz2, then pi to px2 is equal to pi to py2. Is equal to, I said you, because they are in the same energy level. And this one is pi star to px1. Alright, here it will be sigma 2pz. By mistake I wrote sigma 2s. This is sigma 2s, sigma 2pz2. Alright, in this way we got it. The electronic configuration. What is the nature? Paramagnetic, one unpaired electron. What is its bond order? Bond order is C. Count the first bonding. 2 plus 2, 4 plus 2, 6 plus 2, 8 plus 2, 10. See, 2 to 4 to 6 to 8 to 10. First without star. So we got it. Bond order is 10. NB. Now anti-bonding is 2 plus 2, 4 plus 1, 5. So 10 minus 5 by 2. So 5 by 2 is 2.5. We can say that bond order is 2.5. What should be the bond order of oxygen? 2. It has to be 2 because number of bonds is equal to that many bond order. Got it? So I told you the last class the bond order can be fractional, but covalent bond is always integral. It's always a whole number. We can say that. So you can see it comes here fractional. How it comes fractional? I explained you. So bond order is 2.5. We got it. Clear? So we got the nature as paramagnetic. I told the electronic configuration. Middle one, you will write it down this one. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2 is equal to pi 2py2, and then pi star 2px1. Alright. This is about your some of the more examples I gave you about molecular orbital diagram. Thank you.